I had no idea how nervous I'd be. There's nobody here. Example C. Again, let's take a look at another one, another quadratic-like problem. Let's go 4x to the negative 2 plus 11x to the negative 1 minus 3 is equal to 0. Now, this one, quite easy to make a mistake on. What don't you like about this problem? Again, to ask that same question again, what don't you like about it? Students are going to say, I like x to the negative 2. I don't like x to the negative 1. Some students are going to say, I don't like math. Well, that's not you guys. You guys love math. X to the negative 2 is what we want to get rid of with this. So how do you get rid of an x to the negative 2? So off to the side, I'm going to think to myself for just a second. X to the negative 2, that's the same thing as 1 over x squared. Okay, if I wanted to get rid of that, what would I have to multiply by to cross off that x squared in the bottom? I'd have to multiply by x squared on top. So what I'm going to do up here, multiply both sides by x squared. Remembering again, x to the negative 2 means it's down in the denominator, really. That's where its home is. Right-hand side, 0 times x squared is 0. Now, as you're considering this, there's one possibility that this would not be an okay step to do. That's if x was equal to 0. If x is equal to 0, in that case, it would not work out because we would not have a correct denominator there. So just to verify real quick, our original problem, if you had 0 there, you'd have 0 plus 0 minus 3. That's not equal to 0, so this is an okay step. But just off to the side, to make my math teacher happy, I'll say this doesn't work if x equals 0. Multiplying through, get 4 times x to the negative 2, which will just give you 4. X squared times 11x to the negative 1 gives you just 11x. X squared times negative 3 gives you negative 3x squared. Okay, probably don't like the form of that. Let's put that in fit standard form. So we have negative 3x squared plus 11x plus 4 is equal to 0. Probably also don't like that negative as the leading coefficient, so let's multiply both sides by negative 1. Gives 3x squared minus 11x minus 4 is equal to 0. Now, this one takes us to another type of factoring. Now I've got a leading coefficient not equal to 1. Have to work with that to see what's going to give us a solution out for that. Many different ways to factor it. Let's take a look at one of them. We got 3x squared, so we're definitely going to have a 3x and a 1x. We've got a negative 4 over here. So the factors of negative 4 are negative 4 and 1, negative 4 and 1, negative 1 and 4, negative 2 and 2. So we'll have to do a little bit of guess and check to see what works. Let's plug in a minus 4 there and a plus 1 there, and let's see what we get. Yep, 3x squared minus 4, get a minus 12 and a plus 1. That works out. Let's take that puppy, solve for x. So we got 3x plus 1 is equal to 0. X minus 4 is equal to 0. Solve this guy for x, minus 1 from both sides. You get 3x is equal to negative 1. Divide both sides by 3. X is equal to negative 1/3. Other side, the easier one, just add 4 to both sides. X is equal to positive 4. So our solution set for this one, x could equal negative 1/3, or x could equal 4. All right, again, pause for a second if you need to talk through another one or see how that worked out. Let's take a look at, again, some more. Again, we're going to get a little more challenging. Again, this section, lots of different types of functions, different types of ways to work through these. Next one, we have some fractional exponents. Let's take a look at another example, example 4 in this case. Let's go 2x to the 4/3 minus 7x to the 2/3 plus 3 is equal to 0. Now, this one's a little bit tougher to see what we need to do or what we need to substitute out. The two previous methods that we taught, by either multiplying by a variable to get rid of what you don't like, or by substituting for the variable to get rid of which one you don't like, either one of them can work in this situation. So instructor, just real quick, pause the video, talk about how you want to attack this problem. If you'd like to, give your students a shot to try it out real quick, see if they can get through the first few steps. But see what you'd like to do. What would you like to substitute, or what would you like to multiply by to get this problem into something more manageable, or to turn it into like a quadratic problem? Well, the students here on campus today selected to do a substitution, so we are going to substitute out. The students selected to actually use x to the 2/3 and set that equal to t. So then if we square both sides, t squared, when you square this out, you'll get x to the 4/3. Again, multiplying the numerator 2/3 by 2. Coincidentally, boy, that looks friendly, like that's going to help out up here. Let's take a look and see what we get. We get 2, replace 4/3 with t squared, minus 7, replace x to the 2/3 with t, plus 3 is equal to 0. In fact, before we go on, let me pretty that up real quick. 2t squared minus 7t plus 3 equals 0. Now, once we have this, quadratic like, looks like something we can factor. Let's see what we got out. We got to multiply the 3. We got to get to -7. So with 2t squared, we're going to have a 2t. And a t is one of them, is our possibilities for the numerator. And kind of nice with 3, that's also prime. 1 and 3 are only options. However, we have to get to a negative in here. So if we're going to have 2 negatives there, positive there, we have to have 2 negatives in here. We have 3 and 1 as our options. The 2, if it goes with 3, we get 6. We get a 1 inside, so that's what we got to have. And still equal to 0. Go back, solve for t. 2t minus 1 is equal to 0. T minus 3 is equal to 0. Solve for t, add 1 to both sides. Divide both sides by 2. Other side easier, add 3 to both sides. T equal 3. Now again, just like in the previous one we did a substitution, most students walk out the door with this one, t is equal to 3, t is equal to 1/2, think that's the solution, but unfortunately we got to go back. And this one becomes quite a challenge problem once we got to go back. So we replace t with x to the 2/3. So we have x to the 2/3 is equal to 1/2, and x to the 2/3 is equal to 3. Now here's a tough one. How do we get rid of a 2/3 power? Now if it was 1/2 power, it's easier. We just square both sides. The reason why that works is 2 times 1/2 gives you back to 1. So what would we have to multiply by 2/3 to get it back to 1? And it's to the 3/2 power, so we're going to raise both sides to the 3/2 power. Other solution, again, raise both sides to the 3/2 power. And what do we get out for a solution? Over here, 2/3 cancels out 3/2. So we get x is equal to 3 to the 3/2. And let's even take that one step further. So you have 3 and 2. 3 and 2, let's replace that in square root form. Using the properties of exponents, we have the square root of 1/2 to the 3rd power. That will be the square root of 1/8. Second part, we have 3 to the 3rd power, so 3 times 3 is 9, times 3 again is 27. You might even think that's pretty enough, but let's simplify out them square roots. Do the easy one first, square root of 27. We got a 9 in there we could take out, so we could get a plus or minus 3 square roots of 3. Simplify all the way next door. We got the square root of the top over the square root of the bottom. Made that a little bit too big. Square root of 1 is an easy one. That's plus or minus 1. Square root of the bottom, 8. We have 4 in there, so we can make that 2 square roots of 2. Some teachers will want you to rationalize that denominator, get the square root out of there. If they do, multiply the top and the bottom by the square root of 2. You get x is equal to plus or minus the square root of 2 over 4. Or x is equal to plus or minus 3 square roots of 3. This is a tough one. Probably want to take a second to talk about it. Might even want to work through another example with this one. Again, lots of different functions in this one, lots of different types of things we could do with this. Yeah, tough problem. Good problem. Give you a second to pause again. We have 2 more examples to work through again. Lots of different types of problems in this section. Lots of different types of functions. So we have 2 left. Probably the 2 hardest ones you're going to run into in this. I'll take a look at another example, example 5. These last 2 are radical examples. And not because they're so much fun, just because they have radicals in them. The first one we're going to take a look at is 7 plus the square root of x minus 1 is equal to x. Again, what I continually emphasize to my students is what don't you like and how do we get rid of it? With this one, what's the thing you don't like? What's the thing you don't want to be there anymore? And it's probably going to be that square root. That's probably the toughest part of this one. So with this one, to solve this one out, what we're going to do is we want to isolate that radical, get it by itself. Kind of thinking of the game plan of this one. The only way we can get rid of a square root is to do what? That's to square it. So if we want to square it right now, I mean, think of foiling that out. That's not going to be much fun at all. So we're going to get that 7 over to the other side, then we're going to square both sides and go from there. So first step of this one, minus 7 from both sides. We have the square root of x minus 1 is equal to x minus 7. Next step, now we've got our square root by itself. We want to get rid of that. It's probably the thing we don't want in this problem. We're going to square both sides. Square gets rid of the square root, but also when you do that, when you square both sides, this is the step that creates the extraneous solution. We'll talk about that at the end of the problem. But the extraneous solution is where we're going to get 2 solutions when we should not have 2. We should only have 1 of this problem. So we can square that out. Left-hand side, we get x minus 1. Foil that out, you're going to have x squared minus 14x plus 49. Next step from there, it's easy to solve stuff when it's equal to what? When it's equal to 0. So let's add 1 to both sides. X is equal to x squared minus 14x plus 50. Very last step, that's minus x from both sides, so we just have a 0. 0 is equal to x squared minus 15x plus 50. Again, kind of noticing a theme. Let's factor that out. So we get x minus 5 times x minus 10 gives us 15, gives us 50. So our 2 potential solutions for this one, x minus 5 is equal to 0, x minus 10 is equal to 0. We get x equal 5. We get x equal 10. And there's our 2 solutions out. Might be a good shot to check right out. For any questions, see if there's any.